Okay, let's start our class today with the station of Kitab Al-Fatiha. Okay, so today we will learn about these two things, classification of material, and maybe if I have time, then I will give feedback on your previous presentation, the 8 presenter last week lah. Which is Alif Mukri, Khalif, Iwana, Nabila, Husna, Cik Wan, Huda, Ainun, Najmi, and Alif Syami. But first, we talk about classification first. The term classification. The term of classification. Okay. You have learned before, most of you taking microbiology in primary school or even in matriculation. So you have learned the classification of living thing. Okay. So let's talk a little bit about classification of living thing before we discuss about classification of our material cost. Okay, let's talk about first classification of living thing. So as you know before that you can classify anything that is living into 5 or 6 divisions, 6 big group lah. Which is first is animal. So animal, so let me draw myself and also maybe elephant here. So that is elephant. So you have animal and then you also have plant. So plant here, so let me draw like this. Okay, plant, and then what else you have? You have also fungi. Okay, you have also fungi. So fungi is basically the mushroom, the one that you see, you eat, whatever. So mushroom is not a plant. In fact, mushroom is more near to animal to the plant, because mushroom, they don't create their own what you call food. Plant normally they do photosynthesis and gather the food from this from the sun and so on. But mushroom, they find the food themselves. So mushroom or fungi is more closely related to animal than to plant. Other type of fungi is yeast. Okay, so this yeast. Okay, and then you have 3. And then what else? You have also protista. So you have protista. Okay, what is protista? The example of protista is you learn in, I think in form 4 or form 5. You learn about this paramecium, right? Something like a footprint. You have like the cilia there, and then you have what we call this nucleus there. And also you learn example of protista is like amoeba. So you have this thing. Okay, protista is single cell. So protista here is basically is a single cell. So you see that single cell. Single cell of eukaryote. What does it mean by eukaryote? Is basically you have this what we call the nucleus. Nucleus is enclosed, meaning that you have a membrane, nucleus membrane enclose this thing. And then you have also the bacteria. So bacteria is basically, it's like this lah, bacteria, whatever. This is bacillus, and then streptococcus, whatsoever. The difference between bacteria, normally we know about animal, plant, and fungi, but there are some not many people clear about protista and bacteria. Bacteria you know, but what is the difference between protista and bacteria? Bacteria, if you see the difference between bacteria and protista, is that bacteria also single cell, meaning that they are only one cell. We are multi-cell. But the difference is that bacteria is prokaryote. What does it mean is that inside the bacteria here, meaning that the nucleus is free. So you can see in the bacteria, even though you have this one single cell, the nucleus, normally you see like this, right? You see something like this one dot. So the nucleus, they are constrained in one thing. But in bacteria, it just be like this. The nucleus just go here and there. So that's the difference between bacteria and protista. This is what we call classical classification of living thing. You have 5 things. But not recently, I mean that this classification 5 some people said 6 classification. Some people use 5 kingdom. I mean inside under the living thing we call it kingdom. So some people use 5, so there is 5. Some people use 6 kingdom. When you say 6 kingdom, what does it mean is that under the bacteria, they further sort of like let me put this color. This bacteria, kenapa color macam ni? Okay, this bacteria, they further divide it into 2, which is the what we call the bacteria. Instead of saying bacteria, they divide into bacteria and archaea. Okay, so archaea is basically the ancient bacteria lah. Bacteria. I mean the generic idea about archaea is ancient bacteria, and one of the properties of this archaea is that it have this sort of like they live in the extreme, live in extreme environment. For example, in the hot spring, for example, you have this hot spring, and in the volcano. So let me draw. So when I draw like this, at least in simultaneously I slow down my talking, right? If let's say I have you slide, I will talk very fast. So that's why when I draw like this, write something, so for some of you maybe they want slow down a tone little bit. So this is one way for me to prevent me to go very fast. So this is also the what we call this the archaea again. They live in this harsh environment, the hot spring, this what we call the volcano. So their body, the thing that's coat their body, they have a different chemicals makeup on their body compared to the normal bacteria. So this is when what we call people talk about six kingdom. Normally they talk about animal, plant, fungi, protista, bacteria, and archaea. If people talk about 5 kingdom, animal, plant, fungi, protista, and bacteria only. So that is what you have learned in Form 4 in matriculation. I think you learn in what? Do you learn about this in? Do you take microbiology, Aziha, in matric? Do you take microbe in?
Yeah.
So even now also you take microbiology, even though your what we call your degree is chemical engineering. But remember, sometimes chemical and biotechnology is quite related. Okay, because nowadays people try to produce, for example, making bread, making a wine, also considered is biotechnology, but can also be chemical engineering also, and that's so on lah. So that is classification of living thing. Now we talk about our course. Our course is material course. So to classify the material, let me go down. So we're done with the classification of living things. So let's go to this classification of material. But here in our course, we are focusing only on solid material. So that's the difference, because water also material, right? Ketchup also material. But we are not really consider that lah, because that's more under fluid. Still, fluid is material. Everything that you see is material because it's made of atom, right? The air also material, you cannot see lah, but it's still material. I mean, not in the common sense lah, but still because it's made of atom, so we can consider material. But in this course, we learn about solid material. So that's what the difference lah. How to bowl? I cannot bowl lah. I need to do like this. Solid material lah. Solid material. So this what we will learn. And for solid material, we have seen our presenter before. They talk about 3 things, which is let me put like this. Let's say I draw like this. So you have 3 things. So you have what we call, you have metal, and then you have ceramic, and also you have polymer. Polymer. Okay. So this is traditionally classification of solid material lah. And then if you combine one of it, so you get what we call composite lah. So let's say I put here. So if you combine any one of it, you get a composite. Okay, so you get composite. And then nowadays there are also what we call a class of material that we term as advanced material. Okay, advanced material. Okay, so there are term, let me put this color, the red one. So they are not new. I mean that people classify as an advanced material. So let me put this as a advanced material. So example, normally advanced material they have this 4 category lah. For example, not for example, one category of advanced material is semiconductor. Semiconductor. Later I will go one by one, not in detail but in brief. What is metal, ceramic, polymer, composite, semiconductor, and so on. But for now, just give you the generic idea, the classification of solid material. You have semiconductor, and then you have what? You have also the biomaterial. Let me change this thing. I need to change this thing. Bio, so that I can write like this. Biomaterial. And then you also have what we call biomaterial, and also you have the smart material. Smart material. And also lastly you have what we call nanomaterial. So this what we call the advanced material. And the what classify things to be advanced is that it is used in high tech application lah, high tech technology or application. Okay, so that is generic classification that you need to know lah. So now let's go one by one. Okay, we start with the metal. We start with the metal first. When we talk about metal, later on I will go to this diagram again. But before I go to metal, let's talk about the properties first. Meaning that when you have a material, for example, this pen or whatever, you can sort of like analyze this material based on few properties. Normally when we talk about properties, let's say I put this and I may make like this properties. You can see, right? If when I write you don't see the writing, please tell me. So when you want to analyze the material, you can analyze based on their properties. And typically there are 6 properties, 6 typical properties. So the first one and the most famous one is mechanical properties lah. And let me put this color lah, so that mechanical properties. The second one is what? Is electrical. So you can analyze any material based on this. And third is electrical thermal. So you have thermal also, thermal properties. And then 4 you have magnetic properties. And then you have 5, let me go up a little bit, optical, meaning that whether it's transparent, translucent or opaque, so that is under optical. And then the lastly is basically their degradation, their deteriorative or degradation properties. And this corrosion, for example, corrosion of the metal is fall under this deteriorative or degradation lah. And also recyclability also under this lah, degradation. So this is 6 properties that you can sort of test any material on. Okay, mechanical, electrical, thermal, magnetic, optical, and this degradation. So now let's go one by one. When people talk about metal, first we need to ask, what is the definition of metal? Let's go down. So let's go down. Okay, let's see first about metal. So metal. Let me talk about metal now. What is the definition of metal itself? Okay, so metal, if you want to call something metal, they must have a metallic element inside it. They must have a metallic element. Okay, the word element is important because you know up until now we have 118 elements. So element here. Up until now I think they have 118 elements found, which found and also synthesized. So this you can find it in the what we call periodic table lah. Okay, so this mouse is not element because it's composed of another element combined together. You have plastic, you have metal, and so on. So metal, at least in order to call something metal, you need to have these metallic elements. So example of metallic element is like what? Like gold, like nickel, like what? Like aluminium, and then like silver. Bronze is not tembaga. Tembaga is not element. It's combination of, I think, copper and what, I don't remember. But bronze is not element. So you can see this element. One website you can see is this. So this website I will use again and again. So you go to PT table. So this is what we call a periodic table, the interactive periodic table on the web lah. So PT table, remember this thing, PT table, and then I clicked there. So if you look in this thing, so let me make it small a little bit. Okay, kacau lah kau di sini. Okay, so you see in this periodic table, if you count, there are 118 elements, and you see most of the element. If I click here, so you can see that the color change, right? This and this color change. So if you see metal, the one is not in white. The one is not in white. The bottom one here is the one here. This is metal element. So if you have any element of this, then you can consider the thing is metal lah. Okay, and then you can see metal make up more than half of the periodic table. So most of the element that you found on Earth or you synthesis, because all these element, some of it is natural, some of it is synthesis. For example, those who are above 110 above, normally they synthesis in the lab or whatever. It's not they might have this. They are not naturally occurring. Okay, but below 100 normally you can find it naturally lah. So metal is make up more than 50% of the periodic table. If you see non-metal, is this only the one that you learn in organic chemistry. So you have carbon, nitrogen, oxygen, fluorine, whatsoever. And then you have metalloid. Okay, metalloid is basically the element that have the properties between metal and also non-metal. So for example, silicon. Okay, you have metal, they have these properties of the double properties lah. That's why silicon is used a lot in electronic, because when you have a computer, the most important thing for the computer is basically on or off. For example, 1 or 0, right? So if you can create the entire program just based on this 1 and 0, because for example, if you put 1, then the thing flow, the electron flow or whatever, and you put 0, then the electron stop whatsoever. So you can create a lot of things from that, a program and so on. So this metalloid, for example, silicon, is very, very important for this electronic industry, is because the silicon, they use silicon to make this integrated circuit. Let me show you. Where is this? I don't know lah whether you can hear me or not, but you see me that small so this thing so this Arduino whatever. So you have this, what we call this, mana ni, saya tak boleh besarkan. So saya buka ni wait I make like this, I make like that, open that. So this thing. So you can see here, this inside this, the one that I show there, the black thing is IC, integrated circuit. Inside this, there are billion of transistor. Any computer, they have this transistor. The thing about transistor is that they like a switch. They on and off, and they use this silicon to create this what we call this transistor. And of course, the transistor normally you see in electronic class, you see a big transistor like this. For example, when we talk about transistor, normally you talk about something like this, small pula. Let me put here, something like this, transistor, like this, right? When you learn in electronic class, it's like this. But nowadays they miniaturize it, so they make it small and small. So that's why it can cram into this small IC. Inside this, they have like hundreds of billions of the, not billion, I don't know. But normally normal computer, fast computer, they have billions of transistor inside that. and because of there are a lot of this transistor, you can do a lot of this programming on and off, and you can create the entire program out of it. So that is what we talk about this this thing, this this thing. So that is metalloid. That's metalloid. You have boron, you have silicon, germanium, arsenic, antimony, and tellurium. Astatine normally they are not really used lah, but at least 1, 2, 3, 4, 5, 6 there. You have boron there. You have boron, silicon, germanium, arsenic, and antimony, and also tellurium lah. This 1, 2, 3, 4, 5, 6. The most common, the most notable metalloid lah. People also call this as a semiconductor, because we know that metal here conduct electric, and non-metal here doesn't conduct electric. So whatever in the middle is have this semiconductor. They can conduct and they not conduct. So you can make a switch off of that. So we see about this metal, what we learn now. Let me open this here. So now you can go side here, side there. So let me close this thing first. Okay, so at least you need to have a metallic element. So that's the important thing. And then some people talk about metal alloy. Metal alloy. Okay, what is metal alloy? A metal alloy is basically a metallic is basically metallic also, metallic substance that compose of two or more element lah, two or more element, meaning that they are metal, but they have other combination. Maybe they are metal and another metal, and also it can be metal and non-metal. So that also we can call it alloy. Some people call it composite. So normally when the thing when the metal is the majority, I mean make a bulk of it, then people normally call it alloy lah, alloy. Especially when you have metal and metal combined together, they call it alloy instead of composite. Okay, for example, titanium and gold, they combine together, you have alloy. You have carbon and iron, you have steel. So that's, we call it alloy. Okay, so metal alloy. So the term alloy there, the term alloy. Okay, so what is the mechanical? When we talk about metal, we know the definition of metal is that you need to have metal element. But what is the characteristic? So now let's talk about the mechanical characteristic. Mechanical characteristic of metal. So what is the mechanical characteristics of the metal? Metal is strong. Metal is basically stiff lah. We normally call it stiff. Metal is basically stiff and also what we call strong. Stiff and strong. Strong yet ductile. Ductile. What does it mean by ductile? Okay, ductile mean that is capable to sort of like is capable to withstand large amount of deformation. For example, metal is strong, metal is stiff, but it's ductile. For example, let's say I have here in front of me, this kecil lah, besar sikit lah. It's okay, you hide for a while. So for example, in front of me I have this, what we call the spoon, right? Let me put this curl here lah. So you see there are spoon there. So it's strong. You see it's strong, right? It's strong. It's stiff, meaning that it's not really it's stiff lah. It's stiff, but it's ductile, meaning that when you cap up here, so it's, for example, it's not break. So that's the difference. It's not fracture. But if you have, for example, this popsicle, the kayu ice cream ni, you do like this, and then it break. So that's the difference. Metal is ductile. That's the reason why metal have this widespread use in this engineering construction, because we want something that is strong, something that is stiff, mean that is not like layut macam ni lah, macam ni layut lah, dia layut kan, dia layut, saya panggil layut, but it's ductile. So that when it's ductile, for example, it's able to deform a little bit. Okay, it's not like break straight away like this. So if you see the the concrete bridge, when they break, they break just like that, because it's like the cement. When you break it, then they will sort of like crack, and then they break catastrophically, mean that they don't have this deformation thing. But metal, if you try to put a lot of load on that, still not break. Oh, habis rosak semuanya. Okay, so that's the thing. So that's the idea of metal. You have something that is strong, stiff, but yet ductile. So that's the reason why people use metal in construction and so on. And also, metal also have this non-localized ion. And let me put this color. They have this what we call non-localized electron. What does it mean by this is that if let's say you can see inside this spoon the atom, and you know the atom you have electron around it. So normally for the element, the electron will sort of like be with the atom itself. Okay, be with the atom. Okay, but in metal, if you see the metal in bulk, the electron of this spoon, the inside this thing, is not bounded to any atom, so it's freely move. Okay, later on we will learn in detail about this, how this non-localized electron and so on. But the idea is that the electron inside this is not bounded. It's not like there are no like attachment to any atom. For example, if this is iron, so there are iron, there are electron, but this electron can move along. So because this electron can move along, then the electricity can it become conductive. Because electricity, what does it mean by electricity? Is that movement of electron. So if the electron is bounded, then there are no electricity. But here you have non-localized electron, so meaning that the electron not bounded to specific atom, that cause the electron move freely, so making this thing conductive lah. So that make it conductive. That's why you can generate electricity using the metal. Okay, and metal, they also, if we talk about the optical, you see here they are optical. We also have this optical thing, right? So when we talk about metal in the optical, normally they are what we call not transparent to visible light. Of course lah, this common sense. But there are things that is, for example, why glass is transparent. Okay, glass is not metal, right? It's common sense, but the properties why that thing happen is quite interesting lah. So metal is not transparent to visible light. If you polish this further, metal gives sort of like this shiny, or we call it lustrous, whatever lah, but shiny lah. Shiny. I hope you understand what I want to say lah. Lustrous, shiny, kilau, shiny when it's polished, when polished. So that's one of the another
question.
Yes.
Isn't not the transparency and all that under optical properties?
Yeah, this under the optical properties law. So let me put, so this, whatever you want to see, whatever this under optical properties. The reason why the metal not transparent, that we will discuss later, but having something to do with the grain boundaries, because inside the metal there are atom, but of course the atom, they have the boundaries here and there. So because inside metal there are a lot of grain boundaries, then they become like opaque and so on. But that we go for detail, we go later on when we discuss only metal. This I give you generic overview for all. Okay, by the way, if you have a question, you can feel free, just stop me, say that, oh, I have question like that. Okay, so that's the thing. And also metal also have some some properties which is not like, I don't say it's unique, but yeah, it can be unique lah. It has this what we call magnetic, magnetic properties. But not all metal have magnetic properties. For example, this magnet, this I put this card ni lah. Okay, for example, this. Okay, So this is magnet. This from neodymium magnet. So some metal, for example, if I have this one, okay, this and this, okay. So this, sorry, I'm just use the webcam, so it's not really sharp or whatever, the light. But I hope you can survive with that lah. So this, ay, melekat pula. So this one is steel. This one is aluminium. It's ringan, ringan. It's very very light. This is steel. It's a little bit heavy. If you are in a physical class, I can ask you to feel it. So if you see, if I put this magnet to this steel, it will have this magnetic properties for the steel. But for this aluminium, nothing happen. Nothing happen. Both are metal. So that's why metal, some metal, not all metal, some metal have this what we call desirable magnetic properties. So let's go back here. So what metal that have this magnetic properties? Typically, you have this what we call the most famous one. They are like three famous one. Typically ferrum, ferrum is iron lah, iron, not ferrum, iron, and then you have cobalt, and also one more is nickel. Okay, nickel. The one that I show you, this thing, sorry, this my see this difficult. Okay, like this. The one that I show you, this magnet that I show you, this from neodymium Nd. But the most common one from ferrum, cobalt, and nickel. Ferrum is iron lah. So that's why anything, normally when we talk about magnet, we talk about something that have iron. So anything that have iron, they have this sort of like magnetic properties. If you go to this, what we call the periodic table that we see just now, so you can see where is ferrum. Ferrum is where is ferrum? Ferrum. What is ferrum? I don't know ferrum. Ferrum. Iron. What is iron? What is iron?
26.
26. You have ferrum, iron. You have cobalt and also nickel. So you can see these three: ferrocony and also nidominium. Yeah, this not and B. This is niobium. Is nidonium Nd, I think. Mana Nd? Nd. Yeah, this neodymium. Okay, normally neodymium is when we talk about the strong magnet, normally is made from this neodymium lah. Normal magnet is made from the iron. But cobalt and nickel also can make this magnet properties lah, can give magnet properties. The others doesn't have this magnetic, but you can induce it. But later we will discuss lah. So that is basically about metal. About metal. Let me open this thing again. Okay, so that's about metal. And that's about the properties of metal. And one more thing before we go to the next thing. Let's talk about this metal atom itself. So if you look metal atom, they have this very what we call metal in atom in metal or atom in alloy. They basically arrange in what we call in very orderly manner. Okay, meaning that if you can see the atom inside metal, you can see it's like they sort of like, you know, the askar, the soldier, they arrange themselves. So for example, let's go here. So let me go here. Here, and then let me go to image. Let me put here. Let's go to image. So let me put the what we call gold. Gold is metal. Gold, TEM. TEM is basically equipment. It's like a microscope, but instead of using light, they use electron to see. So TEM, later on we will learn about TEM maybe if we have time. Gold, TEM, image. Mean that people put a thing under the microscope, so you can see here. So you can see the lattice. Let me put you here, so you can see there. See this thing. So you can see is the atom that they can see. You can see is order. You can see it's in order. So that is basically metal lah. Metal, you can see that's metal. So let me see. Okay, let's see this. Okay, so if you see this image, The rest here, they are no order. This is basically what we call amorphous. Later on, when we talk about crystallinity, we will talk about this amorphous and crystalline structure. But for time being, you can see this, the one that have this sort of like fringe of array, a lattice we call it, is a metal. Okay, this is a nanoparticle from gold. This is gold nanoparticle. And the rest is basically they put on the carbon, the amorphous carbon, and then they put metal on that in order to see under the microscope. This is not normal microscope but electron microscope. So you can see you have this sort of like you can see the atom there. Okay, but of course in order to see this you need a very powerful microscope lah, not normal microscope. We will learn about microscope later on lah. But for the time being, this is how atom in metal looks like. In ceramic is different, in polymer is different. You don't see this thing. You cannot see, you cannot really see like this. So here you can see compact and arranged. So that's one of the properties of metal. So let's go back to this thing and then let me open this thing. Okay, so now we done with all the characteristics with the metal. So let's see back what your friend present last week. So metal, I think metal is what? Metal, siapa metal lah? Metal is basically Alif Mukri. Alif Mukri and Cik Wan Huda. Okay, Cik Wan Huda with the tumbler. Okay, so Alif Mukri, if you see the Alif Mukri part, so Alif Mukri here, they talk about this steel, about steel. Okay, Alif Mukri talk about steel. Steel is not in the periodic table lah. Steel you cannot find in periodic table. Steel is basically steel. So the most common metal the most famous metal is steel Steel is basically not an element. It's basically a combination of carbon lah, but the bulk of it is iron plus carbon. Okay, so besi. So this fork is not only iron because iron by itself is very soft. Okay, you might think, oh, iron soft. No, iron is pretty soft, pretty soft. It's not super soft lah, but it's pretty soft. The original iron, the original. Okay, this it become hard like this is because they put carbon inside that, and normally they put around 2% carbon like that inside this iron. Iron is make most of it. 2% of it is a carbon, and then you get the steel. This steel is this. Steel is this. This is stainless steel. Whatever the fork here, stainless steel. If you use steel like this, you can see right this thing. Okay, this is steel. You can see it's rusty. Okay, it's rusty. So this what we call steel steel. This stainless steel. Stainless steel. If you put stainless steel, stainless and steel is basically iron. What this thing? Iron plus carbon. So you use carbon, and also they add chromium. Normally they add chromium. Chromium normally around 11%. Okay, the reason why you put chromium for stainless steel is that if you see steel here, the iron, one of the problem with iron, because even though they are carbon here, the problem with the iron is that if you have this, let me go down a little bit. If you have this, okay, this, let's say this is iron. This iron or steel steel. Okay, and we know steel have a lot of iron in it. 2% is carbon, but the rest is iron. The iron, when they meet with the oxygen, let's say they have oxygen, air lah, udara, atmosphere, then the iron will be oxidized. Okay, when iron oxidized, they create this what we call iron oxide lah, ferrum oxide, iron oxide. So iron oxide, the color of iron oxide is like rusty lah, like the reddish thing like that. Okay, that's iron oxide. So that's why rusting happen because of this steel. They meet with the air, and you have the water and so on. Because air lah, they oxidize the iron, and then you get this thing. When they put the chromium, inside on steel, so you have steel, but also now you have chromium there. So the difference is that the oxidation still happen. You see the oxidation, the O still there, the what we call the atmosphere is there, But now chrome, the chrome, instead of iron oxide, they create this chromium oxide. Chromium oxide. Okay, chromium oxide. Instead of iron oxide, they create this this I put here, iron oxide. Instead of iron oxide, now they have this layer of chromium. Let me put this color lah. Layer of chromium oxide. And chromium oxide, the layer of chromium oxide is transparent. This is transparent. Transparent. And when this sort of like created, it's become passive, meaning that it's not reactive with other the other thing yet lah. Other thing again. So you get this protective coat of chromium oxide, which is transparent. So that's why even though it's oxidized, you don't see the thing because they are like layer of chromium oxide there. So preventing from iron to be sort of like further oxidized and so on. So that is the idea of stainless steel. So okay. So carbon. Okay, let's talk about carbon. Let's talk about this carbon. Why they put carbon? Okay. This have something to do with the nature of the iron atoms. Okay, iron atom. Okay, why they put carbon? Let me put here. Okay, let's say this is, for example, this example of what we call the iron atom. Let's say this black one. Let's say this is iron atom. So iron atom, one of the property, because iron is very soft. Iron is soft and ductile. The iron atom, they have this sort of like tendency to sleep. Tendency to sleep. Tendency to sleep one another. So this, for example, this, the one in green, this layer, they can sleep there. They can just sleep like that. When you sort of like bend it, it's easy to sleep. So when you put this what we call the carbon, for example, the carbon is this red. Let's say this carbon, this red, this carbon. Let's say this carbon atom. When you put this carbon atom somewhere in the middle here, for example here and here and here, so basically the carbon atom act as a stopper. So you sort of like somebody hold you from moving along. So that's the reason why steel becomes stronger and stiff compared to the iron, because iron tend to sleep. So we call this slippage. They have a term for that. They call it as dislocation of atom. So that's the reason why they put carbon, in order to make it strong and stiff, and they put chromium in order to create this chromium oxide to make it stainless, not rusting and so on. Okay, so that's basically why what we call Cik Wan Huda can use her tumbler safely, because remember, if you use this steel as your tumbler material, then you have this corrosion, and the ferrum oxide, not only it oxidize, but also the ferrum oxide will sort of like flake off. So the material, the iron will, if you put in the make a tumbler from the iron, then it rust, and then that rusting thing, even though small in amount, go into your body, and then it will cause this a lot of thing . So that's why most of the cutlery thing in your kitchen is made from stainless steel. But of course, stainless steel is hard. Stainless steel is expensive. Okay. For example, this is iron. This is stainless steel . Let me put here . We go relax . Kita punya kelas ni relax je. Supaya at least my idea, so that you can faham rather than you just hafal. Okay, so this is aluminium. In order to know whether this aluminium or not, is basically you can feel it's ringan. So this same like more or less like aluminium, but this is stainless steel . Stainless steel. So aluminium go away, this go away, this go away. So this is stainless steel. The one that is corrode, this is steel . So this is stainless steel. So as I said before, we remember a little bit before, we talked about magnetic properties, right? If I have this magnet, you know that when I put on the steel, because steel have what we call the iron inside that, and iron have this magnetic properties, you have this you can take this you can sort of like not magnet, I mean that this will be react with this magnet lah. This stainless steel inside the stainless steel there are also iron, but it's not really what we call, they are not really you can feel actually, if you do it physically, you can feel there are some what we call, there are some feelings, you know, when you use a magnet, you can feel the thing, like the force, you have some, you can feel that thing, but it's not so strong lah. Okay, because stainless steel you can make magnetic or non-magnetic stainless steel, so that's we will learn later So that's why there are something, for example, if you use induction cooker like this, let me put like this, induction cooker, let me make it bigger, this thing, induction cooker, okay, like that. Okay, this induction cooker, I don't know, some of you might use it, some of you might have in your kitchen, or some of you might ever have experience with this induction cooker. In order for this to work, you need to use something that is magnetic. For example, this stainless steel, like you can see here, Panasonic, right? This look like stainless steel, and yes, it's stainless steel, but remember, stainless steel, as you see just now, it can be magnetic, it can be non-magnetic. In this case, you need to find the stainless steel that is magnetic. Do I have or not? Wait, I'm not prepared for that lah. But anyway, this collar, okay, this magnetic, magnetic. But if you go to the hardware store, if you buy this what we call collar here, some of them is not magnetic. If this is not magnetic, then you cannot use this. You cannot put on this. It doesn't work. It must be magnetic. So that's why material, even though it seem like similar, is like, I have this non-magnetic one, but I don't, where I put That's like in that class I show, because I have to show you, to prove that there are something that is not like this. It's collar also, but it's not magnetic. Just to show you that things like normal, like stainless steel, there are a lot of story behind it. Because there are stainless steel that you can buy, but if you buy the certain type of stainless steel, then you cannot use it for this induction cooker. For this, that's why I don't like this thing. I mean, the advantage of using this induction cooker is that it's very fast. You can boil the water in 1 minute. It's very fast because you use magnetic field and so on. If you use gas, normal stove gas, stove S-T-O-V-E, stove gas like this. Okay, so it use gas. But the advantage for this, you can use anything. You can use ceramic. You can use what we call, you can use stainless steel, magnetic or non, whatever you can use here. But for this, what we call the one before, you can only use for stainless steel. You cannot use ceramic, whatever, and to sort of to cook on that thing. That's why you can see all the image there. All the image here is stainless steel, right? All the image is steel. It's not. So even this tefal, here, there are special tefal. I mean, sister no lah. Tefal is like this cookware. So there are tefal that is can be used on this induction cooker, which is magnetic, but there are which is non-magnetic. Normally the one that is non-magnetic is cheaper lah. It's cheaper. But for example here, if you look here, you can see here, thermopot. There are certain tefal they cannot use you cannot use on the induction cooker. There are some you can use. So knowing about material, the metal itself will help you to sort of like getting the idea of all this thing lah. Okay, so let's go to this again. Let me go that again, and then go here again. What's more about metal? Because I think it's already 9:21. So if I go to ceramic, then it will stop halfway. So I think maybe I will stop here. So I will ask the question. As I said, at the end of the class, I will ask the question about what you have learned. Whoever can answer then get bonus mark. So the bonus mark here is 1%. Okay, I have maybe 3 question. Okay, 3 question. Okay, let me go down first. So we have learned today. We have learned about metal and classification and so on. So we go like this lah, class. Like. Just one by one. At least you can remember. So question time. Okay, the first question. Tell me about classification of living thing. Explain. Okay, anyone? Name. Give name.
Noha.
Noha. That sister do first. Siapa Noha?
Yes.
Okay, Noha. Dia. Okay, Noha. What classification of living thing? Okay, so Noha, in order to get 1 mark, so this is 1 mark. In order to get 1 mark, you need to explain lah. Explain.
Okay, classification of living things. We usually use kingdom to classify the things that under living things. So there are 5 or 6 kingdom. So the first one is animals, and the second one is plants, and the third one is fungi. And fungi and plants are not same, because plants used to make their food by their own, while fungi they not create their food by themselves. And fungi is it's more related to animals and not the plants. And the third one is protista, where the example is Paramecium, amoeba, and they are single cell of eukaryotes, where nucleus is enclosed, and the fifth one is bacteria. Bacteria is the single cell, where this one is nucleus free. So the nucleus will move freely, compared to protista, where it is enclosed. And if there are 6 kingdoms, so the bacteria will become there's bacteria and archaea, where archaea is the ancient bacteria. So this one will usually be found in extreme place, where for example in hot spring and volcano.
Okay, thank you Noha for that. So you can get 1 mark. Okay, so second question is about tell me about advanced material. Name.
Iwana.
Okay, Iwana.
Okay.
Advanced material. Tell me about advanced material.
Okay. From the diagram, you showed us, advanced material too would be the group that is consists of metal, ceramic, polymer, and also composite, which are combination of those pair, either metal, polymer, metal, ceramic, any of that. So advanced material, there are 4 yang major, which are semiconductor, biomaterial, smart material, and nanomaterial. All these 4 are mainly used in high technology, and are more applicable compared to the rest. So yeah, those are advanced material.
Semiconductor, nanomaterial, biomaterial, and one more. What is?
Nanomaterial.
This they are nanomaterial. Nano, semiconductor, biomaterial. One more.
Smart material.
Smart material. Okay, thank you, Iwana. So the last question for today. Tell me about mechanical properties of metal. Name. Alia.
Yes.
And name Alia. A-L. Do we have Alia here?
Why?
Alia. Let me see. Alia. Can you tell?
Alia Zainab Radha.
Alia. Where is Alia? Alia. Talk a little bit. Alia.
Alia.
A-L-I-A. A-L-I-A.
Aleeye.
Cuba cok. Alia this. This one. Alia Atikah.
Alia Zainab.
Alia Zainal. What is Alia Zainal? Oh, Alia. Alea. You later on you tell me your name is Alea because to sort me differentiate Alia. So you make hardcut sikit. Okay, so tell me the properties of what we call the metal.
Properties of metal. The six properties of metal. It's mechanical, electrical, thermal, magnetic, optical, and liquidation. So I will explain about mechanical characteristic or mechanical properties. Chemical characteristic of metal is stiff or strong. Why is it strong? It is because it is not localized or delocalized electron. So it's freely moved, not bounded to any atom. So that and that is also the reason why it is a good conductor of heat and electricity. And then it is tactile. Tactile is capable to withstand large amount of information. Means that we could shape a metal into any desired form. For example, for sculpture, um, we could use metal. And then there is optical properties. It is not transparent, means that it is not visible from light visible. And for metal, if we polish it, it will just become shiny. It will not. It will not become. It will not become transparent. It just will shiny lah. And then there some of it does magnetic properties such as ferrum, cobalt, and nickel. Not all of the element for metal could have the magnetic properties, just some of it. Then for degradation, some of it like iron will corrode when react with air, and some of it will not lah. That's all for me.
Okay, thank you, Ali. Yeah. Okay, so the last question is for the four people here. So either one of you, only this 4 person in front of the open camera now, because normally I also give the chance for them lah. Okay, the question. Apa question nak kasih ya? Okay, tell me about stainless steel. Name. 1 person only. So this 4 person, anyone? Tell me about stainless steel. Raise your hand or just talk lah. Tell me about stainless steel. If no one want to say, then I will choose from. I will open. But for now, I give this 1% bonus mark chance for any of you, the 4 person in front of me now. Last question. Tell me about stainless steel.
Sir.
Siapa nama you tak ada kat bawah ni ah? Siapa? Nama you?
Adam.
Adam eh?
Ah.
Okay, Adam. Tell me about stainless steel.
Okay. Stainless steel, as you said, that it consists of iron, carbon with 2% and chromium 11%. And it's the difference between stainless steel and the normal steel is steel can rusty because when it oxidize with oxygen at the atmosphere will so that we can see the rusty. So and the but in stainless steel, it consists of chromium, and the chromium will form oxide and by oxidation, and it will form a thin of layer on the steel so that it can avoid from the steel and avoid further oxidation of steel and oxygen. And carbon, uh, for the carbon in the stainless steel, it prevent it from like the iron atom. It is a tendency to slip easily to sleep with one another. And then the function of carbon in the stainless steel is to prevent it from sleep and make it stronger. That's also.
Okay, thank you. What we call Adam. So I think that's it for today. It's already 9:32. So that's today for about what is the thing? So today we have learned about what? We have learned about this classification of living material. We have learned about classification of solid material. You have metal, ceramic, polymer, and then composite, and then you have advanced material. We only now cover this part, metal. At least give the big overview of this metal. So next class we go ceramic, polymer, composite. We see how long it take. But yeah, so this give you the overview of this thing lah. So that's it for today. Thank you for all. If there is any question, then you can ask me in WhatsApp group because I don't want to prolong this class anymore. So that's it. Thank you everyone. We end our class with a recitation of Tasbih, Kafarah and Suratul As.